Welcome to demonstration of the EPOS-Norway web portal, which will be introduced by following a scientific use case. I have chosen the Limnic eruption phenomena, which is a natural disaster where dissolved carbon dioxide suddenly erupts from deep lake waters. The CO2 spreads around, and because it's heavier than air, it can cause deaths by suffocation around the lakes. In addition, a tsunami can be created. This phenomena is linked to meromictic lakes. Meromictic lakes are those lakes where the water stays stratified in a water column, which means it's not mixing throughout the depth. And I found on Wikipedia that actually there are also such meromictic lakes in Norway. In fact, there are 6 of them at least. I've chosen the Salvatnet, which is the biggest in Norway, and it's north in Trøndelag. So let's move back to the EPOS-Norway portal. First, have a look where the lake actually is. Switch to display mode and create a globe view by clicking the globe icon. Here I can also choose different background layer. I will choose OpenStreetMap. And now if I zoom in, the lake is right here. If I navigate to the left-hand menu, I will open the project, and by default there is a project, but I will just now rename it to Limnic eruption, and I will save it. So now it's everything saved in my project Limnic eruption. Now I want to add datasets to my project. So I go to the search and find, where I have 2 bar charts, one for category and one for service type. I can use them for filtering the list of individual datasets in the table on the right hand side. So first I would like to check the geological map. So I can use the geological data category and the service type as map layer. And here I see that I have bedrock geology maps available. So I can explore the info, which is very basic info and link to the data provider. And I want to add it to my workspace, which appears now here in the selected datasets/service. Second dataset I would like to add is the seismological data, and I'm interested in seismic events from National Norwegian Seismological Network, NNSN. Again, I will click add, and it's added to my workspace. Now I will switch back to the display mode, and I can change the layout. Now I have 2 plot windows. I would like to have 3 windows. So I click this 3 dots here, and I will change layout. I would like to keep 2 columns, but I would like to have 3 tiles instead. If I click OK, now I have 3 different views in my project. To optimize the content of the dataset, I can select it. Once I do that, the content is displayed in the dataset service contents below. Here are descriptions or individual columns. If I want to see the content, I can just drag and drop it to the table view, and it's rendered. So I see in the catalog of earthquakes, I have 77,621 earthquakes. I can also visualize the earthquakes in a map. So if I now go to the content, I find latitude and just drag and drop latitude to y-axis. Similarly for longitude, but to x-axis. So I see I have some earthquakes around here. In addition, I would like to highlight or use the magnitude as a size attribute. and, for example, depth as color scale. Well, now I need to adjust the visualization slightly, which I can do through this palette button. If I click it, I can first modify the color scale. For example, here I'm interested only earthquakes up to first 50 kilometers depth. Similarly, I can adjust the magnitude scale. So if I click the magnitude, I can intentionally downscale the magnitude so I can see better differences in earthquakes. So now I see that around the Salvatore Lake there are some earthquakes. I would like to do the visualization in a better way. So I will add yet another plot, which is scatter plot. And here I would like to see the magnitude as y-axis and, for example, time as x-axis. So now I see the catalog being plotted in time. And if I'm interested in the area around the lake, I can press Alt button and make a selection in the map, which means I'm selecting earthquakes only in this area, and at the same time the only selected earthquakes are also highlighted in all other plots, which means in this scatter plot and also in the table view. So now I see that I have 22 earthquakes which are distributed from year 1990 up to 2012, 14, and the dataset actually I can now download if I select this one in comma separated value format. If I want to see how does it compare it to depth, I can actually remove this plot and choose scatter plot again, and here I can plot magnitude against depth. All plots are still linked, so I can see that the events are up to magnitude or around magnitude 2, the maximum, and the depth is actually relatively shallow. So I can zoom in by pressing the middle button on the mouse and just moving the mouse cursor to the right. And then I see that the depths are actually down to 25 kilometers, all being located in the Earth crust. Now I would like to compare it. How does it look like the geology in the area? So now I switch to the WMS service, and here I'm interested in the Berggrunds. So I will just drag and drop the layer to the map, and it immediately renders the layer from the remote server at NGU. When I want to zoom in, it actually seems that this server is not providing high resolution data in this layer. But in addition, I can put the second layer into the map, and then we immediately see more details. But at the same time, we need to adjust the transparency of the layer. So actually we can see where the lake is and then investigate what is the actual geology around the lake. Okay, so if I click now in the map, a new window is shown and it shows it's igneous granite or foliar granite in this area. If I switch back to the map, it's pretty much all around the lake, which means there is no loose masses deposited around the lake which could cause sliding into the lake and mixing the water in the lake and then potentially triggering limnic eruption. So by this scientific use case, I introduced the very basic functionality of the EPOS-Norway Portal. Thank you for watching.